So, today we will demonstrate how to measure the focal length of a convex lens. So, in last two classes we have seen how to measure the focal length of concave mirror and convex mirror. So, for measurement of focal length of a convex lens, so this it is procedure is same as the measurement of focal length of a concave mirror. So, for concave mirror you have seen that, or for mirror formula actually in working principle, the mirror formula we have used, that is 1 by f equal to 1 by u plus 1 by v, right, or 1 by v plus 1 by u. Now, for this convex lens or for lens, this formula has to be replaced by this 1 by f equal to 1 by v minus 1 by u. Okay. So, in concave or convex mirrors we use this formula, but for convex lens or concave lens the formula we will use, that is 1 by f equal to 1 by u or 1 by v minus 1 by u, right. And in ray diagram we will replace the concave mirror by the convex lens. So, what I am trying to say, that procedure is same, only in working formula you use this lens formula, as well as the ray diagram whatever we drawn in case of concave mirror. So, there just you place this convex lens. Okay. So, basically this ray diagram will be like this. So, you have a convex lens. Now, convex lens like concave mirror, they are converging lens or converging mirror. Okay. So, this lens produce the image, whether it will be virtual image or it will be real image, that depends on the distance of the object from the mirror. So, if object is at infinity, so we will get image, we will get real image, and that we will get at the focal point of this lens. Now, if you decrease the distance between the object and lens, means if you are bringing the object from the infinity towards the lens. Okay. So, when this lens this object will be the distance will be greater than 2f or greater than radius of curvature of the lens, then the image will be shifted from focal point, it will shift it away from the focal point. So, in that case it will be between f and 2f. When you will bring to the object at the 2f, then it will be at 2f, image will be at 2f, and all image will be real and virtual, real and inverted one. Okay. When this object will be between f and 2f, then this image will be beyond the 2f, and it will be real image and inverted one. Okay. So, when it will be at f, object will be at f, then image will be at infinity. When this object will be so far whatever image I told, so all will be real and inverted. So when the distance of the object is less than f, it is between focal point and the lens, then you will get erect and virtual image. Okay, you will get erect and virtual image, and basically you will get in this side. Okay, so here in experiment, so we'll keep the object approximately at between f and 2f. Okay, then we'll expect that image will be beyond the 2f. Okay, so if you to know the approximate focal length of this lens, so just you can uh, put the mirror, you can put this, not mirror, this lens below a say light, it's too far from this lens, and then you will see this, it will this light will focus at a point. So that distance will be basically focal length, approximate focal length. So one should find out that one, and then you keep this your object more or less 1.5 times from the 5 times of the focal length at that distance, more or less. Okay, and then you try to see the image. Okay, so image will form say here. Okay, so now how to find out the image position, that's what we use parallax method. So what is that method? I explained already for in case of mirror. So you have to change the position of the object needle in such a way that the image, inverted image, you will see through this lens, and the point of this inverted image and the point of the object needle, okay, tip basically. So first you should try to take them at the aligned. Okay, take them aligned. That means these two tips will coincide. Okay, so first try to find out that distance. Now more or less that object image position will be there. Now you have to remove the parallax. So for that you just move your eye towards left and right and find out the position of the object so that these two teeth will not detach, they will move towards left and right together. If they are not moving together, they are becoming detached, and image and the image needle, that tip, they are moving when you are moving your eye towards left and right. So that means it is not the right position. So you have to adjust this object position to not object position, image needle position to find out the position where there will not be any parallax, means they will not be separated on movement your eye towards left and right. Okay, so then we'll take the reading of this position of the object needle. Okay, then position of the lens and position of the image needle. Okay, so basically this is object distance u, and this will be the image distance v. Okay, now we'll change. So basically for each object position we'll take 3 reading, we will take 3 reading, uh, 3 observation basically. So, average of that observation we will take as a average position of this object needle, image needle. Okay. So, then second set data we will take just changing the position of the object needle, say plus minus 2 centimeter, plus minus 2 centimeter. So, from this position. Okay. So, say here whatever, so shifted by 2 centimeter this side and repeat the experiment, find out the position of the image needle. Okay. Record the data. Okay. So, next set of data you take this this object position on the other side by 2 centimeter. Okay. And then repeat the experiment, find out the needle position, object image needle position. Okay. By parallax method and record the data. Okay. So, then if you will find out u and v, and sign of u and v is basically, for u it is negative and for v it is positive. So, using this formula f equal to uv by u minus v, you can find out the focal length of f, and it will be basically positive. So, basically image is formed this side. So, this is the focal length distance, that is the focal length of the lens. Okay. So, you need table to record the data, So, data for u and v. Okay. So, here serial number of observation, position of object needle, then lens, then image needle. As I told, image needle you take 3 observation, then find out the average of that image reading. Okay. So, now observed distance is basically u and v, o dash, o dash and oi. Okay. That is v. Now, corrected distance, as I told that corrected distance means if any index error is there. Okay. So, how to find out index error I explained. Okay. I am not repeating. So, that if any correction is there, then you should do that correction. So, I assume here that there is no index error. So, then for plotting graph, you can plot UV graph as well as 1 by u and 1 by v. So, as same as concave mirror. Okay. And from there you can find out the basically from the graph you can find out the focal length. Okay. So, let me do the experiment. So, this is the same optical bench. It has meter scale. So, 0 to 150 centimeters, right. Now, this one is basically convex lens. So, we put convex lens in a holder, lens holder, and that holder we put on the upright. Okay. So, upright, so that we can change the position of this, it can move on the optical bench. Okay. So, and this is the object needle, So, I fixed that object needle at 0. Okay. So, index mark is coincide with the 0. So, let it be fixed, and then so this lens I have seen, I think I will not repeat that one, but or I can do that. So, initially what you should do, so you should try to find out the approximate. Yes, I can see, you see here. So, this is the length of this this is the length of the focal length. It's around, we have seen, I do not have scale here, but I think I have a small scale. So, from here I can see it is approximately, the scale is not good one, but uh, this is the scale reading, I can see 20 to 30 this side. Okay. So, approximately 10 centimeter. Okay, approximately 10 centimeter. Okay. So, then put it here and fixed it. Okay. So, to move it, just you have to press it and just move it. Okay. So, since it is around 10-12 centimeter focal length, so I will keep object distance from the lens is 1.5 times. So, say let me keep this, then I have to keep this lens is say 15. Okay. If it is 10 or 12, so let me keep it at say 17. Okay. Okay. So, focal length is 10, so it is 20, 2f is 20. So, I am keeping the object distance 1.5 times more or less. Okay. So, I am keeping here and I should check the image whether it is, one has to be very careful because it is very sharp, it can hit your eyes. So, actually I should also get very nice image of the, yes, image of the needle. So, I can, it is within f, so I can get the image now. It's a defocused. So, that way also one can guess that what is the yes, focal length. Okay. So, I think it's disturbing. So, I have to remove this one object. That's the, we will use as a yes, this the around f. Now it started to be inverted, but yes, I got it. Yes, I got it. Okay. So, I am keeping approximately around say around 15, 16, 17. There is no problem. I can see the image. Yes, I can see the image. Okay. So, we will note down this position of the image object needle and the position of the lens. Okay. It is around 17 now, it is the 0. Okay. Now, I have to take this image needle. I have to take the image needle, and first what I have to do? I have to change the distance, and first that inverted image tip and the object, this image needle tip should coincide. So, now it is not coinciding. So, if I take away and then it is going to coincide, yes, it's coincide, yes, at this position it coincide. Okay. So, now after coinciding I have to remove the parallax error. So, there is a parallax. So, I have to adjust the uh, position. So, let move that way and see, yes, I am going close. No, I have to come this side. Yes, it's reduced, parallax is reduced. No, it's more parallax. It's less. So I should, no, I have done more. So, this is the important for this experiment, you know. One has to have patience and find out, and this cannot be unique position. Okay. So, it's really I'm not okay. Yes. So, this is the position. Of image needle. So, I should note down the data. Okay. Observation 1, and then object needle distance here is 0, and then this one is 17. So, one should, yeah, more or less I am taking just how to take, uh, one should not have parallax error. So, needle image, it's 55 point, I can see 55.8, 55.8, okay, 0.8. So, as I told, this is not the unique position. So, one should again try to find out the better position. Okay, take 3-4 observation. Take 2-3 observation. Now it is 55 point, I can see 4. Okay, 55.4. So take 3 observation and then find out the average of that one. Okay, so then you will get the u and you will get the v. Okay, and then second, you should, what you should do, second observation, second set of data you take. So you change the position, you change the position of the either needle, object needle or the lens. Okay, so I will change the, that means u I am changing. So let me keep at say 19. Okay, keep at 19, and then I will keep other side this 15. Okay, or keep at 15 and then 15. It was 17 earlier, so now 15. I will again find out the S. Now it's the so I have to change the position and find out the S. So what happens? I kept that it is 15. That means this u value now it is close to the f. Okay. So if object is at f, it is at infinity. Now, so if it is greater than f, so it is coming, image will come towards, from the infinity towards the lens. Okay. So if distance is now it is less than earlier distance. Okay. So image needle, it is expected that this image will be away from the lens compared to earlier one when the distance was 17. Now distance is 15. So earlier whatever this, it was 55 point something, so it should be higher than that. This reading should be higher than that. Okay, so that you can from the theory of the lens you can guess, you can assume that one. So it should not be less than 56. So this is very important for this experiment, you know. So one should find out, yeah, more or less I am getting here. So now reading is 64 point 64 point around 6, 64 point around 6. Okay. So this is the 0 position, this is the 15, this is the 64.6. Okay. Then you take more 3 reading, find out. Okay. So then you put at 19, lens you put at 19, it is 0, this third one. Okay. So you can take not only these 3 reading, so you can take more readings, say 21, 23, 25. Okay. So, this way you should have 5, 6, 7 reading, because we have to plot graph. So, when you will get this u and v and corresponding 1 by u and 1 by v. So, now you plot graph that same way as we have plotted for concave mirror, right. So, in this case v is positive, as I showed you, v is positive, and u is negative. So, so for concave mirror, v and u both was negative. Okay. Now, here is the positive and this is the negative. So, you have value of u and corresponding v you plot, okay, you will get this type of curve. Now, same way you from this curve itself, okay. So, you know where when v will be equal to u, okay, where this object is at 2f, object is at 2f and image also you will get at 2f. Okay. So, whatever uv you are getting, so that is basically so your f will be ov. So, this is u and this is v. When they are equal, no, this will be, so this will not be f, it should be 2f, it should be 2f ov equal to OC, right, OB equal to OC. So, when you get image and object at the same distance, when it will be at 2f means at radius of curvature. So, other one also I think I have written wrongly. So, this has to be 2f, 2f will be equal to why it is O? Oh, okay. So, what is the formula? So, 1 by f equal to 1 by v minus 1 by u, right. So, when v and u are equal, so this you can write and sign will be opposite sign, right. V is positive, u is negative. So, it will be 1 by v. So, plus say 1 by 1 by v, same distance, u equal to v. So, this will be 2 by v, okay, 2 by v. So, 1 by f equal to 2 by v. So, f equal to v by 2, okay, f equal to v by 2. Okay. What is v? V is OC or OV. So, here I have written wrongly. So, basically 2f equal to not 1 by v. So, equal to OB equal to OC, okay, equal to OB equal to OC, right. So, f will be half of it, f will be half of OC or half of OB. Similarly, if you plot 1 by v versus 1 by u, so here basically y equal to mx plus c. So, OC, that is the intersection on the y axis. So, that will be 1 by f, intersection, that is c. So, basically whatever OC value you will get, so that is basically 1 by f. So, f equal to 1 by OC, okay, whatever, because here it is 1 by v, okay. So, here it is v. So, that is why it is the 1 by OC, but not here 1 by OC, okay. So, I did mistake. So, I corrected it. So, now f equal to whatever this you will get OC. So, 1 by OC will be the f. Okay. So, using the graphical method one can find out the focal length. Okay. So, then one should find out the error in the calculation. So, how to calculate error, you know, I am not going to discuss that one. So, in next class I will demonstrate how to measure the focal length of a concave mirror. Okay. So, not mirror, concave lens. So, then I think we will know how to measure the focal length of mirror, concave mirror and convex mirror, as well as lens, concave lens and convex lens. So, for convex lens this is the method. So, in next class I will discuss for concave lens. So, I will stop here. Thank you.